I want to demonstrate a fun way to explore polar graphs using the Desmos graphing calculator. So I'm going to pick on number 53 here from the textbook, r equals 5 sine of 3 theta. So what I want to do is be able to trace an endpoint as theta goes from, say, 0 to pi. So to make that happen, I first need to create a variable to trace with. So I'm going to use the variable a. I'm going to start it at 1, and I'm going to let it go for now from 0 to 2 pi. And I'm not going to worry about the step. Then I'm going to enter my polar function as r equals 5. And let's see, this one was cosine. No, this one was sine of 3 theta, and we just spell out theta. And so it'll draw the graph for me. Now, I don't get a good idea about how this graph was created, so that's where I use A. So what I want to have Desmos do is start the graph at theta equals 0 and just go up to the value A. So I'm just going to put A here as the endpoint for theta. So then what I can do is I can move the slider for A to see how this graph is traced out. So if theta is 0, then the sine of 0 is 0. So I'd start at the origin or at the pole here. And then as theta increases to, say, where are we at there? So let's see, pi over 3 is a little more than 1. So by the time I get to pi over 3, I've crossed through. So let's just double check. Calculate pi over 3 radians is 1.04. I'm at 1.06. So it completes one leaf of this as theta goes from 0 to pi over 3. And then it's going to create the second leaf. And so then I should be finishing that around 2 pi over 3. So let's check. We can just double this guy here. So around 2.09, I'm at 2.1, and I've just finished the second leaf. So 1 pi over 3 for the first leaf, 2 pi over 3 for the second leaf, and then we can keep tracing. It should complete the third leaf by 3 pi over 3, which would be pi, and notice 3.15. Just before that, 3.14 is a little less. Can I get to 3.14? Almost, not quite. At 3.13, I'm not quite there. And then if I go past that, I don't see anything happening, so I'm assuming it's tracing itself. There is a way to plot that as a point. It's a little tedious, but it's not too bad. So you could actually see a point floating around there too. But just the idea of having a trace variable here that we can set as a variable endpoint so we can see how the graph is being created. So now I can see if I have 3 times theta, I'm going to get a 3-leafed flower, and the period of it is pi. I hope that trace idea helps you explore other graphs.